One second, one second. You need to write this. Okay. Hello, guys. You hear me? Let me know if you can't. All right. So, are you okay with question 1? Okay. Question 2. Okay. All right. Thank you, sir. Thanks for your help. So let's. All right. I'll just do the first part of question 1, if you don't mind. Right. So the derivative of this with respect to x is times the derivative of this, which is all right. So this is the derivative of the Gumbel distribution, right? That's question 1. The other two are similar, so I'm not going to do them. Now, let me move on to question 2. Question 2 is to find the mean. Yes. Oh, it's upside down. Come on. Going to build video setting. This one? Top one, this one. Oh, okay, okay. Right. Okay, now. All right, so this is the derivative of the Gumbel distribution, density of the Gumbel, right? Now, let's do question 2. So we want to find the mean of the 3 different types. So starting with type 1, I'll just do the thing for type 1. Okay, so this is gonna be, because this is defined from minus to plus infinity, gonna be x multiplied by like this. Okay, now to do this integration, you can do it in different ways, right? Now, what I will do is to make a substitution. Yeah, so set y equal to e minus x. So that means x is equal to minus log of y. So dx by dy is minus 1 over y. Right, so put this in a box like this. Now sub this into the integrand, you get x will become minus log of y, then e minus y, dx is minus 1 over y times dy. Okay, and the limits of integration, when x is minus infinity, y is plus infinity, and when x is plus infinity, y is 0. Okay, are you guys with me so far? Let me know if you or including those in Zoom. If you're not following me, please use the chat room, right? Okay, so the y and the y here cancels, right? And there are 2 minuses, so you get this. Yeah, correct me if I'm wrong. I hope I'm correct. Yeah. Now to change the limits around, because it goes from infinity to 0, you want to change it back from 0 to infinity, right? So you introduce a minus sign when you yeah. You know that, right? When you change the limits, you need to multiply by minus. Yeah. Now, one trick, I don't know whether you know, is that if you have, I think I talked about this last week, if you have something like y to the power a, and you're differentiating with respect to a, then this is y to the power a times log of y. I mentioned this last week, right? You remember this? Yeah. Now, if you take on both sides, left and the right, you should set a equal to 0. And if you put a equal to 0 here, which is y to the power 0 times log of y, this is log of y. So let me put this in a box, right? Right, you see what I've done? I put things in a box, right? Now what I'm going to use is I'm going to, I forgot to mute. All right. Okay, now what the thing I'm going to do is I'm going to replace the log of y here by the left-hand side, right? So this becomes This becomes this, yeah? Now, the next step, I'm going to take the derivative, the operation of derivative outside of the integral. I mean, in practice, you cannot do that always, but you have to satisfy some certain conditions. But in this case, I will assume anyway those conditions are satisfied. So yeah. So yeah, you're with me. Now, finally, you may know familiar with this. I don't know whether you know something called the gamma function. Are you familiar? If you're not familiar, I will write it down what it is. A gamma function is a gamma function at alpha is defined as follows. That's okay. As t power alpha minus 1 e minus t dt. So this is the definition of a gamma function if you don't know it already, right? Now using this definition, you can write the above as d by dA of the gamma function at a plus 1. Okay, so this is simply minus the derivative of the gamma function. I'm using this at 1, right? So that's the, are you guys with me? So that's the answer for the mean of the Gumbel distribution, right? Are you okay with that or not? Right, and similarly, you can do the mean for the Freshie and the mean for the Weibull, which I'm not gonna do, right? Okay, so let's go back to, can I take this away? I mean, I will put a scanned version of this on the course website. So there's no, if you cannot copy it right now, you can copy it later on, okay? So we're done question 1, question 2. Question 3 is to find the variances of this, which is similar. So I'm not gonna do question 3, all right? It just find the variance. So just like the mean, you find the variance, right? So let's move on to question 4. Question 4 is to show that this is equal to this if and only if, all right? So let's see how we can do that. So this is question 4. So it says, we want to show that okay. Now the lambda is so this is the same as saying that yeah. Okay. Right now this, if you take the nth power of this, what would you get? You will get e minus n times yeah. Yeah, and then you should take the log of both sides. You take the log on the left-hand side and the log on the right-hand side. You will get minus n yeah, and the minus cancel. So you get n yeah. Now, the next thing I'm going to do is I'm going to take one more time, I'm going to take the log on the left and the log on the right. Okay, so if I take the log on the left, you get log of n plus the log of this, which is minus x. And the log of the right is minus alpha n x minus beta n. Right? Now, what you need to notice is that this is a constant term. This is a term that involves x. This is a term that involves x, and this is a constant term. So for these two to be equal, the constants must be equal. So in other words, the constant on the left-hand side is log of n. The constant on the right-hand side is minus beta n, right? And the coefficient of x on the left-hand side is minus 1. And the coefficient of x on the right-hand side is minus alpha n, right? So what we have shown is that beta n is equal to minus log n, and alpha n is equal to 1. Okay, so that's the question, I believe. Is that right? Yeah. So that's how you will do it. Okay. Any questions, guys? You okay with that? All right. Good. So that's question 4. We are done. So question 5 is similar. Question 6 is also similar. Question 7, I think I did this as an example in the class. If you look at the video, I'm sure you guys watched the video, right? And this is one of the examples I did in the video, right? So I'll move on to question 8. Now, by the way, this term, max domain of attraction, when I say, I know some of you asked me this question, the max domain of attraction means basically asking you which of the 3 types holds. Like, so if type 1 holds, then you say that the distribution belongs to the Gumbel domain of attraction. If type 2 holds, then you say that the distribution belongs to the Frechet domain of attraction. And if type 3 holds, then you say that the distribution belongs to the Weibel domain of attraction. All right. So in this case, we want to find the domain of attraction for this guy here. So let's see how we can do it. So it's question 8. We have f of x equal to power alpha, where x is positive, right? Now, the first thing you must find out is the w of f. So you set fx equal to 1, which implies that equal to 1. This implies that equal to 1, and this implies that minus ex equal to 0. So e of minus x is 0. So x must be plus infinity. Now, the reason, so you follow me, right? So what we have shown is that w of f is equal to plus infinity. Is kind of clear from the question, because if you look at the support of the distribution, which says that x is positive, so the largest point of the domain of the CDF must be plus infinity. So that's your upper end point, w of f, right? All right, so let's check condition 1. Condition 1 says that the limit as t approaches infinity just give a shout if you can't follow. Give me a shout. Hello. All right. Okay, so this is what you get. Now, one formula, I don't know whether you know this from your math courses that you have taken. Do you guys know this result? That if you have something like 1 minus z to the power alpha, it behaves like 1 minus alpha times z if z approaches 0. Do you know this or not? This is, I mean, it's a basic result. You might know this or you might not. If you don't know this, try to remember this, okay? Okay. Now, as you can see, as t goes to infinity, this guy goes to 0, right? And so is this one. This also goes to 0 as t goes to infinity. So we can use this result here. You follow what I'm saying? Yeah. Because in order to use this result, you need to make sure that this term here, z, approaches 0, right? Which is the case here, right? Right. So using this result, you can see okay, this is what you get, right? Now the 1 and the 1 cancel, the 1 and the 1 cancel. So you get, this is the limit as t approaches infinity of alpha okay. Now the alpha and the alpha cancel. So this becomes the limit t goes to infinity and the of e of minus x gamma of t. Right? And this is equal to e of minus x if you choose gamma t to be identically equal to 1. Okay. Right? So remember the type 1 condition says that the limit must be e of minus, right? And so therefore the condition for type 1 holds. So the conclusion is that f belongs to the Gumbel domain of attraction. Is this all clear to you guys or not? Are you guys okay? Yeah. Yeah, all right. So we are doing question 8, which you just came. We are doing question 8 of the week 2 tutorial sheet. Right? Any questions, guys? All of you okay, guys? Yes. Sorry, I can't hear you. Yeah, maximize. Make it bigger. This one? I don't know. I have no idea. Well, you mean like this? Yeah. Like this? Okay. All right. Thank you. Any other questions? You okay? All right. So let's go to the next. So we're done with 8. Question 9 is something that I did in the videos. So I'm not going to go through that. This is something I did in the videos, right? you watch the videos, you will know the solution. So let's look at question 10. Question 10. Question 10 is, you have fx equal to 1 minus k divided by x power a. You should say x is greater than k, although the question doesn't say that. All right, the first thing you need to figure out is what is w of f, right? So you put f of x equal to 1, right? Which implies that 1 minus equal to 1. Yeah, so the 1 and the 1 cancels. So this implies that equal to 0. Yeah. So zero. So x must be plus infinity. So W of f is plus infinity. Right? Right. Now let's check. Let's start with condition 1. Right? So for condition 1 to hold, yeah. Right? Now clearly these two guys cancel out. Okay. So what you have is, I'm doing it slowly, but I mean, I could do this in one step if you want me to, but just I'm doing it slowly just for the benefit of you guys. Right, so let me do this slowly. Right. Now the k in the top and the k in the bottom cancel out, right? So what you have is right. Okay, now the question is, for the condition 1 to hold, this guy must be equal to e of minus x, right? Do you think it can be equal to e of minus x? Yeah, so I mean, there's no chance. It doesn't matter what you choose, gamma or t, to be, there's only one x here, right, in the bottom. Right, so there's no chance this is gonna be equal to, right? So that means the f cannot belong to the sample domain of a fraction. So let's go to the condition 2. So we're gonna check condition 2. Remember, condition 2 says the following: is the limit as t goes to infinity of this, right? So this is gonna be limit like this, right? So once again, the 1 and the 1's cancel. So what you have is the limit as t goes to infinity of yeah. Now the k and the k cancel, the t and the t cancel. So what you have is that this is equal to x to the power minus a. Right? And hence condition 2 is satisfied. I remember the condition, yes. Yeah, you can do that like that, yeah. Yes, the answer is yes. Right, so the conclusion is that f belongs to the Fresher